Okay, welcome back. So let's look at now a feature we would like to add to the binary tree. So far we were able to create the insertion method to actually add data as we also added nodes to the tree. So every time we added a pair of data, which is a key and the actual payload, we added a node, and starting from root, and then the children downstream from root. So at this stage right here, this is the insertion method that we did in the previous video. Okay, so now what about if we wanted to look at the actual binary tree, and let's do it sorted. So we're going to call that method in order. So it will sort the data for us and display it from smaller to larger based on key. Okay, so we're going to have a print statement here for BR1, the object BR1, with the method in order, named in order. So let's create the method in order. And the way to do it is we're going to do the same technique, let's see here, that we did with insert, right? So we're going to have an overloaded method, and which means one that has a specific set of parameters and then a different kinds of parameters here, but it's the same name of the method. And we will definitely do what? We will have recursion within the insertion method. By the way, this insert method is really a service method for this one. So we can make this one private. So there's no need to make it public. So the only one that we really need as a public interface is this one right here, since that's the one we're using here with 2 arguments. So we're going to do the same thing. So let's go back and create our in order method. And the way we're going to do this is this way. So public, and we would like it to return an actual string, since we're going to print that to the screen. So string, and we're going to call this method in order. Okay, and it will take no arguments. However, we're going to have an overloaded version of this method that would be private to support it. But right now, this simply will return, and we're going to start at root, in order, at root. Now notice this one here takes an argument, so I haven't defined this. No wonder you get this squiggly line here. That's because I did not define it yet. So can we do something with that? Absolutely. So the way to do that is maybe something like this. Private string in order. So this will be the overloaded version, except this time it will take a node. So data node, and we're going to simply return right now, just return an empty string, just so this will compile for us, right? So here's the basic architecture of how we're going to do in order. By the way, we're going to replicate this for pre-order, post-order, so the other techniques for displaying the content of the BST or the binary search tree. So what can we do here? Oh, by the way, I mentioned search, so we're going to have a search feature as well when we get a chance. All right, so let's go to main and actually put a print statement here. So system.out.println, and we're going to print, and we're going to say this one is the in order, and then we'll do something like this, /n maybe, and plus br1 dot, and we're going to use the method in order here, semicolon. Okay? So if you run it, obviously we're going to get nothing out of this other than, let's see what's going to happen here. Right? So we just get in order, blank, right? So now we would like this space here to be occupied by this data here, so on the screen, but sorted based on the key. Okay, all right, so let's go back to here. And we're going to do all of that logic in this private supporting method. First, we're going to check if the node is not null, because if it is null, return blank. There's nothing in there, right? So you haven't even populated root. But if node is not equal to null, then we got a whole bunch of things we can do right here. Else, guess what? You will be returning this blank here. Now, obviously, we need to do something here. We need to have a return statement here. Otherwise, you'll end up with this squiggly line here. This will not compile because you have a conditional statement. So what are the things we want? Well, we want to output a string. So we're either outputting this blank here or the concatenation of all the toString return method, or the return from the toString of every node. Aha. So we could do something like this: string output, and that's the one we're going to be outputting back here, right? So when we're ready to do that, so what can we make it equal to? Well, we can start by calling the inOrder method and supply it with the left-hand side node dot, and we're going to do get left. So this will be the component that steps us through the tree recursively. As we do that, so it's going to return a string for us. As we do that, right? And we're going to concatenate it with the node and dot toString. And we're going to add a little space there to separate those fields. Okay. And then we're going to do it again where the output, and this time we're going to go on the right-hand side. Okay. So notice this thing is sandwiched between two calls to the same method. We get to see this pattern change when we do a different method like post order, pre-order. So pay attention to this area here. So in order, so we're calling recursively in order, right? And this time we go right. And this would be get right. Let's put a semicolon there. Once we're done with all this, then we will return the actual output, the concatenated string. All right, well, let's see what kind of results we're going to get here. So let's go over here and let's run this. And there you have it. So what did it do? It reordered everything on the output with the lowest key first, all the way up to the highest key. So this is the inOrder method to peek, or literally read the content of this binary tree and sorting it based on the key values, right, that identify each node and its position within the tree. All right, so for the next video, we're going to do a pre-order, then we will do a post-order, then we'll do a search, and then we'll do a delete. So each one will be a separate video, by the way. I will see you then.